Hi there, Science 9. So what you see, what we're going to cover just now are the materials for the notes for Lesson 4, Solar Energy, Weather, and the Seasons. I certainly suggest that you check out the YouTube resources and also go through some of this notes information. First of all, weather versus climate is one thing you should be familiar with. They both relate to things like, is it raining or not? How warm is it outside? What's the cloud cover? What's the wind? These are all related to that, but weather describes short-term patterns in that. We might say, yesterday, for example, there was a major hailstorm. Today, the weather is cool and cloudy. These are statements about short-term patterns and changes in these variables used to describe what happens in the atmosphere. Okay? Climate is a different thing. Climate is long-term patterns in that. So whereas we might say for Smithers yesterday we had lots of hail, a large hailstorm, a statement about climate could be like, well, on average every year, Smithers has hailstorms about, 5 days per year has a hailstorm, if I'm guessing. So statements about climate are related to long-term patterns. Statements about weather are individual events. The next thing I'd like you to know about is this concept of the axial tilt. This is a lot easier to illustrate in a classroom, but this diagram does okay at it. The thing to know is, imagine the Earth as the solar system is like a dinner plate, a round dinner plate. The Earth, imagine the Earth is a round marble at the edge of the dinner plate and the sun in the middle. The plate itself is the plane of axis of rotation of the Earth around the sun. The thing about the Earth is it doesn't orbit with the North Pole straight up and the South Pole straight down if you follow that kind of flat dinner plate analogy. Instead, the North Pole, the axis of the Earth, the axis from the north to the south, the imaginary line that joins the two poles, is on a permanent tilt. The Earth is always tilting, and it's tilting always at a constant angle relative to the plane of orbit of the Earth around the sun. This is actually what causes the seasons. In this diagram here, we see that the distance of the Earth to the sun changes hardly at all over the course of a year. Very, very little. But the tilt is permanent. Something to realize here is that I like this diagram a lot, but it's not perfect because it kind of implies that the Earth is somehow rocking back and forth. It's not doing that. What you're seeing there is the result of the Earth being on a tilt for sunlight on the surface of the Earth over the course of a day. So let's look at when we hit, say, December 21st. You're going to notice on December 21st that the North Pole is facing away from the sun, and that's over the course of the entire day on December 21st. In fact, the North Pole is facing away. If you're on exactly the North Pole, the sun will set on September 21st, and it isn't going to rise again until the 21st of March. If you're on the North Pole, you have a 6-month day. The other thing to look at here is, let's look at the angle of sunlight. If you're, say, at point E, let's track point E, right? It goes from here to here. That point E is the equator, all right? And now it's going back down. Whenever you're at the equator, this is not about how far the Earth is from the sun. It's about the angle of the sun's rays. Notice this, that when you're at, look at this, Arctic. When you're at the equator, here's the equator right here. This here, that variable right here, describes the angle of the sun at 12 noon. And we see that on March 21st, that's going to be 90. Try and follow that. And on September 21st, on June 21st and December 21st, that's going to be, Yeah, on March 21st and September 21st is 90, and in June and December 21st, it's going to be at its least because that's when the sun is over one of the tropics lines. Here we see this C means Tropic of Cancer. Down here will be the Tropic of Capricorn. What's happening is, let's watch the Tropic of Capricorn right there. That was September 21st, when the Tropic of Capricorn is where the sun's at a 90-degree angle. If the sun is directly overhead at a 90-degree angle, what this means is that the sun's rays are really focused on you. I guess what I'm trying to say is that a little bit of all the sun's rays are filling a very small amount of space. Whereas if you're, say, on a very small amount of the Earth's surface area, whereas if you're, say, at point A, those, for any point of the Earth's surface at point A right here, the sun's rays are spread out over a very large area. Because they're so spread out over such a large area, there's not much energy to go around, and this explains the overall pattern, which is that it tends to be at the equator where you get the most solar energy and it's the hottest. And as the further towards the North Pole or the further towards the South Pole, the less energy is reaching you because the angle of the light, the sun's angle, is higher. Let's look here at the very North Pole, right? We've got this very sharp angle. When you're at the North Pole, in fact, the sun's angle in the sky is never going to be more than around 47 degrees, as we're seeing right here. Actually, I shouldn't say that. If you're at the North Pole, it's never more than 23.5 degrees. Here, the Arctic Circle, it's about 47. So it's the tilt of the Earth as it orbits the sun that causes the seasons. And where you're located on that ball that is the Earth determines overall the patterns and how warm or how cold it is. The other thing I wanted you to be looking at here is Earth's air circulation. Now, there's two ways of showing this that I found two good resources. One is this, and the other is this right here. I really like this, watching it, because what you're seeing when you're watching this is real-time data of the winds that are moving along the surface of the Earth. Those lines there that look like little comets, that shows wind currents. Something I'd like you to notice here. This line right here, we have the equator. And along the equator, look from here to here, we've got lines. Wind is moving in this direction. Here, north of the equator, south of the equator, wind is also moving in that direction. Those are called the trade winds. These are long-term winds that you'll experience if you're in this tropical area between around 30 degrees south and 30 degrees north. The winds that move in that direction, that move towards the west, are persistent. If you're between 30 degrees south and 60 degrees south, or between 30 north and 60 north, in other words, if you're in the temperate areas, the overall pattern is a westerly, where the winds are actually moving from the west towards the east. Although there's a lot of other factors affecting that. And then we have also in the north, extreme north and extreme south, we have these polar cells where, again, the winds are moving towards the west from the east. This is a consequence of the fact that the Earth is always rotating and leaving some air behind as it does that. This is kind of the trade winds here, and the polar easterlies are a consequence of that. And the westerlies kind of move in the opposite direction as a consequence of forcing from this, the easterly, the polar cell, and these, the tropical cells. What's happening over here, look at this, these yellow arrows. This is what we've got here is the surface of the Earth is warming up. The warm air rises, and it moves towards the poles, and then falls again at about 30 degrees north. And this is kind of a circuit. It's a moving around in a circle, except because the Earth is rotating, that air gets kind of twisted towards the west. And that indeed really is what we're seeing right here on a real-time basis. These trade winds, which are long-term patterns, are being shown as of right now when I'm doing this video. This is the pattern of winds on the surface of the Earth. And we see, if we look at the Pacific Ocean as well, same thing. Those are called the trade winds because they were very favorable to early traders, people who would try to, I don't know, like explore for spices and send sailing ships on trade journeys. They needed wind that was reliable, that would carry them from place to place. And the trade winds were particularly useful for that. So if you're, say, right here in London and you want to get some cinnamon, well, you can take as long as you get down into the trade winds here, you'll get pushed across the Atlantic Ocean really quickly. Things become a little bit more difficult, and as you enter the temperate areas, this area right here around the southern tip of South America is really difficult for sailing ships. But then if you can get your sailing ship further north along the coast of South America and back into the tropics of the Pacific, you can fire your ship across the Pacific, again being pushed by these strong trade winds that take you in a westerly direction. So if you're in a sailing ship, it's a lot easier to sail with the wind at your back, and the trade winds would let sailors do that. So that's really what I want you to know. I would write this on the whiteboard, but I think it looks better this way, is the cause for the season being the permanent tilt of the Earth, about the plane of rotation of the Earth around the sun. That as the Earth rotates, it causes, as the sun heats the Earth, it causes air to rise and then fall as it cools down, which would circulate in a spiral, except for the fact that the Earth is rotating constantly, which then pushes the air in that direction. And that if you look on a real-time map of the Earth's wind patterns, that these overall patterns of air moving to the west in the tropics and in the polar areas stays, and then we have these sort of patterns that move against it somewhat in the temperate latitudes. That's all I want you to know for lesson 4, and I hope your ecosystem in a jar project is going well.